Hi, I'm David Kais, and I run R for the rest of us. You may think of R as a tool for complex statistical analysis, but it's much more than that. From data visualization to efficient reporting to improving your workflow, R can do it all. On this podcast, I talk with people about how they use R in unique and creative ways. I'm delighted to be joined today by Nick Tierney. Nick is a statistician, data scientist, and research software engineer with a PhD in statistics. He recently transitioned to private consulting, offering services in data analytics, modeling, code review, R package development, teaching, and mentoring. Previously, Nick worked at the Kids Research Institute Australia and as a lecturer in business analytics at Monash University. Nick is a passionate advocate for open source software, having developed numerous R packages that improve data analysis workflows. An outdoor enthusiast, Nick hiked the entire Pacific Crest Trail in 2023, completing a 5-month journey from Mexico to Canada. Nick, thanks for joining. I'm really excited to speak with you today.
Thank you so much. It's really good to be here. And yeah, it's funny to hear your own bio that I read aloud, but yeah, thank you.
Yeah, no problem.
I've been looking forward to this. Yeah.
Great. So you have a blog that I have read over the years. It's called Credibly Curious. I'm curious, maybe first of all, if you could talk about what's the significance behind that name.
Yeah. I've always been someone who's had a lot of questions. I think in the classic thing where kids always say why, I said why a lot, and my parents would have parent-teacher interviews where the teachers would be like, "Just you ask a lot of questions at home." And I'd be like, "Yeah, we actually encourage them." They're like, "Oh, it's just you ask a lot," and so I feel like I have often been someone who's like, "Oh, like I enjoy being curious." And then there's a quote from Albert Einstein, I think, that's like, "I have no special talents. I'm only passionately curious," and that really resonated with me, and so that's something that I feel like I've identified with a lot. And yeah, I started a blog in 2012, 2013. 2013, when I first started my PhD, I wanted to sort of kind of document things I learned along the way. And I'd been sort of inspired by other blogs like Rob Hindman's Hindsight blog. And Hindsight is like such a good name for Rob Hindman because
Definitely.
It's about hindsight, looking back at things. And also his name's Hindman, and he does forecasting work. So it's just like, it's a good name. Like, well done. And I wanted something that sort of was about curiosity. So I thought about like passionate curiosity or something to sort of like tie back to the Albert Einstein quote. But Credibly Curious felt like, like I'm doing a PhD, and at that time I had an undergrad in psychology. I just finished that in my honors year, so I was like, I have some credibility. And so, yeah, it just felt like a name that had a little, yeah.
Yeah, that makes sense. So why don't you talk a little bit now, maybe about your background? I know you did your undergrad in psychology, and then you did your PhD in statistics. And I guess I'm curious in particular, like how you were exposed to R and how you came to use it as regularly as you do now.
Yeah, I was really inspired in my final year of psych by a course called Public Health Psychology. It was the first time I'd seen stats that we'd learnt about, treatment A and treatment B applied to a population level, and it had just never occurred to me somehow that you could do that. I don't know. Sort of instead of n or 20 or 30, you have like n of a million or several million, and the impact of that was really exciting, and I found quite inspiring. So I wanted to pursue health and stats stuff, and I just kept asking around for people who knew of jobs in that space. And I ended up landing a research assistant job at Queensland University of Technology with Kerry Mengerson. And basically I remember I sat in her office and she just started piling up these books. I was like, so this will be good, this will be good. And one of them was the R book by Crawley, I think. It's huge, like you'd hurt yourself if you dropped it. And I remember spending like a day trying to read in a CSV or something, and like getting a professor of stats to help me read a CSV file. It was like asking them to it's like asking to use a jet plane to use like the overhead light. It
Yeah,
was
yeah.
just like, sorry, this is but yeah, I struggled with it. It was so hard. It was just something about file paths. I can't remember what the problem was. It all seemed like it should have probably like my working director is set somewhere else or something that's hard to debug. And
Yeah.
um, the group that I was in was the Bayesian Research and Applications group, and there's about probably 15 PhD students and probably another 5 or 10 postdocs who all pretty much exclusively use R. So from the start, I was in this little really supportive group of people who I could go to and be like, I don't understand like this thing, and someone would usually have time to sit down and like very kindly explain it to me. Um, so I got really lucky in that I feel like a lot of people when they learn R, it's sort of a bit of a silo journey, whereas everyone in
Yeah.
that group is using it all the time. So that helped really foster that, helped me get through that initial steep learning curve, I guess.
Yeah.
Um, yeah, and then we did a data viz section in our lab group meetings, and someone was like, there's this thing called ggplot. And everyone was like, oh man, this is going to mean we don't have to teach people how to use for loops to make like separate subplots. That's going to be awesome. And then I was like, who's this Hadley Wickham guy? And just sort of like started reading all of his stuff and his packages and his papers. And then, yeah, and then I basically just got really into like, I could sort of see his like philosophy in that. And then had the opportunity to meet him at a stats conference in Australia that he presented at, and seeing him talk about dplyr was like, whoa, that's huge, and just, so those ideas, I think the initial guidance of the group that I was in was incredibly important. And also like, yeah, getting early exposure to ideas from people like Hadley Wickham and also Yi Huishi about R Markdown and naniar, and those things just felt like right. And I had so much frustration with coding because it just felt like things seemed harder than they should be.
Yeah.
And these ideas from Hadley and Yi seemed to like resonate with me, that they felt like, quote, like right.
Yeah.
It felt like an easier path.
I mean, that was my experience when I remember learning R, and I did the classic like silo thing, just learning on my own. And I didn't kind of realize initially there was like, a base R approach versus a tidyverse approach. I mean, you don't know that, right? When you're starting out, if you're learning on your own, you're just like, I want to learn R. But it was only when I came across the tidyverse that I was like, oh, this actually clicks now. Like I get the kind of design principles behind it. So
Yeah.
that's made a huge difference for me as well.
Yeah, absolutely.
Why don't we fast forward a little bit and talk about the work you did? Tell me, first of all, what is the Kids Research Institute Australia, and what kind of work did you do, and how did you use R there?
Yes, the Kids Research Institute Australia, they have been through a couple of name changes over the past couple of decades. People in Australia might have heard of them as the Telethon Kids Research Institute. I hadn't. Before I'd heard of them, I thought the name was a bit unusual. But they are a research group that primarily focuses on research outcomes for children. Some other similar ones in Australia are like the Murdoch Children's Research Institute, or QMRI, which is the Queensland, it's like the Berghofer Medical Research Institute. It's effectively a research institute attached to a hospital who do work on cancer and treatments and alcohol and like mental health and this kind of thing, and drug abuse, and also vaccine development and that kind of thing. So it was a really amazing environment because we're actually in the hospital, and I'll be at my computer, and then on my left was like a big fishbowl of a lab. So there'd be people in white coats like pipetting and looking in microscopes and doing stuff.
Wow.
And it was really cool to have that connection because you could look over and you're like, oh, like I'm coding and doing statsy things, and then over there's some people that are doing science and like writing in notebooks and doing the science there. The group that I was in was called the Infectious Disease Ecology and Modeling Group. So that's a group that's led by Nick Golding, and it's work around infectious diseases like COVID and influenza, but also things around malaria and other vector-borne diseases, so things that are transmitted by things like mosquitoes. And yeah, so but yeah, that's a bit about Kids Research Institute.
Yeah. So the way I think initially came across your work was with the naniar package, which is one of a couple of packages that you've written that deal with missing data. It seems like missing data is something that you particularly care about. I'm curious where that, well, first of all, is that true? And second of all, if that is true, why? Why do you care so much about missing data?
Yeah, it's a bit of credit to my last year in psych for this. Actually, we in our fourth year stats unit, the lecturer had one or two lectures on missing data, and I just remember it blowing my mind. They're like, "So here's missing data." And we're like, "What do you mean? Like you collect your experiment and you have the data?" And they're like, "Yeah, but sometimes you just don't have the data." And I was like, "What? That's crazy. What do you do?" Like it was like, of course there's missing data, but it just like had blown my mind because so many of all of the examples we'd been given were all like perfect little. So
Of
like
course.
you conducted your experiment, and then you've like also had an analysis plan, and then you basically crank the handle of an ANOVA, and then out comes a p-value, and
Right.
you make some inference on that, which is how they teach a lot of the modeling in psych. It's a lot about trying to think carefully about designing your experiment alongside your statistical model so that you do this, so that you can make like a more informed decision and not p-hacking and stuff like this. So that idea was planted there about missing data existing. And then the first data set I got in my PhD it was something like 7,000 rows. And I was like, wow, I'm working with big data. And it totally wasn't. And then, but I thought it was I thought that was a lot of rows. And then about 60% of the data was missing. And we had like probably 50 or 60 columns. So it was a reasonably large data set. And I just remember being so like, I was like, wow, this is wrong, have all this missing data. And it just felt like there weren't really good guidelines or ways to get sort of at this. Like, how do you even start looking at it? How do you break it down? And I guess a lot of my work on missing data then was just kind of trying to unpick this problem and just trying to make it easier. And I often say sometimes that I kind of hate missing data because it's so annoying, and all of this development was kind of frustrated. It was like frustration driven. And I guess there's a passion sort of underlying that. Like, I
Yeah.
want to make this easier to solve so I can think about this more clearly and in terms of the things that matter. Because missing data, I think I've over the years come to this idea that basically one of the things that makes missing data hard is that it's adding an entire new dimension to the data that's unknown, and that is what makes it hard to grapple with. So how do you like reason about that? But yeah, it was the fact that there was like 60% of my data that was missing. I'd misheard something someone said about decision trees. They said, because I had just learned about classification and regression trees, I thought they were awesome. And someone's like, oh, they're using that to impute missing data. And I had like misheard the word impute, and I just thought that they had said something about using it to explore missing data. So then I applied a decision tree to predict which variables were important for predicting whether like the number or the proportion like of missings in a given row. And that ended up being really, really useful for exploring the data, because we found out really quickly that there was actually some key variable that was like what type of data this was. And basically there'd just been like a bad merge of the data sets of like human level stuff and machine level stuff. So humans don't have like a dust recording, and a dust recording machine doesn't have a pulse. And so when you join all this data, you get huge amounts of missing data.
Sure.
And so very quickly we could explore that. But it's like, those are some of the things that led to me kind of exploring missing data and like just wanting it to be easier and wanting to understand why 60% is missing. And turns out there was like a key variable that explained most of it.
Yeah, and that's kind of what I mean. Full transparency, I've never actually used naniar, although I've like suggested it to other people. But
Yeah.
what it does, tell me if I'm wrong, is it like it allows you to kind of easily see. I know there are like ways to make like charts pretty easily, some graphs that
Hmm.
show like the percentage of missing
Hmm.
observations, for example. Is that accurate?
Yeah. So the work I did in my PhD was then like picked up with my postdoc with Di Cook um, at Monash University, and so yeah, the work we did there was we there's a lot of convenience helpers to explore like how many missings you have in a variable, how many
Mm-hmm.
missings you have in a row, how many common sets of missings you have. So like where are the times when variable A and B go missing together, or A, B, and C, or just A, and then you can kind of arrange those so they're easy to view. But yeah, so there's a lot of helpful data viz. There's also this idea of what we called a shadow matrix, um, which was binding a copy of the data column wise. So you create an entire copy of the data and then you name it. If you have A, B, and C, you name it A underscore NA and B underscore NA.
Mm-hmm.
This is useful and computationally expensive, but it stores an initial copy of the data. So then if you do like any imputation and other things, you have this other way to compare if something is missing or not, or was missing, and so you know if it was imputed, because one of
Mm.
the issues with imputing data is you don't know then if it was missing because it's now complete.
Yeah.
So having this, and so that was based off some earlier data viz work, I think done in the late 80s by Deborah Swain and Andreas Bouya. Um, so that was one of the really great things about working with dyes. There was like a lot of really good background knowledge to the problem of missing data and trying to visualize it and like things
Mm.
people had done. So that was sort of some of the quote theory
Yeah.
underlying it. Was there were these other things that then once you use them, you could then apply that to creating useful data visualizations and also understanding imputations and other things. But there is a lot of convenience helpers in
Yeah.
Narnia, which I think are really useful.
Yeah. So, I mean, obviously, one of the things that you do a lot is develop packages. So,
Mhm.
the reason, I mean, I invited you to chat just about many things, but one of the things I want to spend some time on is about writing tests in packages.
Yeah.
Because I know it's something that's really important, but it's also something I have actually never done. I have created R packages, like we work with clients, we create R packages, but some of my consultants who I work with have written tests, but I've never done it myself. So I'm curious, first of all, if you can tell me like what is a test and what's your spiel for why it's valuable to write
Mm.
tests when making a package?
Yeah. So I guess I want to start this by saying that a lot of my thoughts on this are basically things I've learned from people like Hadley Wickham in his book Art Packages. And so I feel like a lot of what I'm saying feels similar to what he said. So I
Mm-hmm.
guess, so like, firstly, thanks to Hadley Wickham and also Janet Bryan for the Art Packages book, but also like, um, yeah, these ideas I think are common in a few places. But the a test is a way to ensure that your code has like a stated output. So that might be you might have an expectation that your function that you wrote um, will always return a data frame, or you might have an expectation that it's going to return variables with certain names, or that it returns at least one row. And then also it might be other cases like I assume that if I give it bad input, it's going to error. Or I assume if I give it this weird output, it's going to tell me something specific about how to deal with what I've given it. So it's about ensuring that your code is reliable and it works in the way that you really like when you think about it, the way that you expect it to work.
Can you give me an example of like something that would, say a function in a package that would go wrong that having a
Mhm.
test would be able to help you identify that issue in advance? Does that
Mhm.
make sense?
Yep. So something that would go wrong. So the reason for tests existing in this formal way of stating all these things, because it does. One of the things I found weird about it was that I wrote this function. I know it returns a data frame. So why do I need to test that it returns the data frame?
Mm-hmm.
It seems kind of like it's like almost a tautology.
Right.
Um, the reason is that if you make changes to your code, you want to be sure that that it's still behaving the way it was.
Hmm.
And so I guess one example in this might be I wanted to check, say that the grouping, so if you use a group by in dplyr, I wanted to make sure that the group by characteristic was still held on to when I did stuff with naniar. And so that I write tests to make sure it still inherits from, I think it's the groups at df, it gains an extra class when you do a group by statement. And there were some changes to dplyr that then meant that that was dropping, which meant that my code was breaking, and that was something that was able to get picked up. So it's kind of like insurance, I guess, is one way to look at it.
So it's almost like, in some ways, less, making sure that your code does what you want it at the moment you write it, although maybe there's some of that, but also ensuring in the future when, you write other functions that maybe interact with that function, or functions in other packages change, that your code will still work the way you intended to. Do you think that's a good way of putting it?
Yes, and I also think, it's kind of like future proofing, but also you kind of do tests when you write your code anyway. Like when you write some code, you kind of play around with the console and be like, okay, like what does this do?
Right.
What does this return? And trying to remember that for every function that you do, if every time you made a change and you wanted to make sure the function still did the same thing, then that would be like, it's just a lot of extra stuff to carry around in your head. So it's kind of like trying to take those ideas and formalize them. So then you don't have to think about it again. The other thing so there's also this idea of test-driven development, which is you write all of your tests before you write the function. So then all of your tests fail, and then the function is complete once all the tests pass. So this is like, you expect a certain number of columns, or you expect a data frame, or you expect a certain class of input or output. And once you state all of those expectations, it then means that you're really clear on exactly what you want the function to do and exactly how you want it to behave.
That makes sense.
Which is a bit more of an extreme framework. I don't think it's as popularized in R, but in other programming languages, a lot of people, it's like how they do everything.
Yeah. Well, let's actually have you help me to learn a bit about writing tests. So let's have you, put your screen up, and we'll talk about this internal package that we use for various things, and talk about the best way to add some tests to it.
Cool. Another thing I want to say about tests actually was basically that it forces you to really examine your code. It almost makes you, like, have you heard of the idea of rubber ducking your code?
Yeah.
So it kind of forces you to do that again, which is kind of like you have to really sit through and explain it again, and kind of almost like this Feynman technique of explaining to like someone younger than you or someone who doesn't know as much, explain the concepts again, which forces you to kind of revisit things in a different way. So I'm looking at your code here. Was there a certain file that you were curious at looking at for tests, I believe?
Yeah, I mean, I think initially we talked about maybe the ggplot theme, but that might not be.
The ggplot theme actually worked quite well.
Let's do that if that works, because that's, I'm trying to think of like kind of what's the simplest.
Yeah.
So, yeah.
Cool. Have you got some example data of videos with ggplot?
Good question. No, I mean, I usually just write something with like empty cars or
Cool. So we can use that.
penguins or something. So.
Great. So let's start with use underscore test that. Actually, before we do that,
test that is the name of a package, right?
Correct, yeah. So to test that as an R package, if I had the Wickham & Co., the tidyverse theme, and it sets up this testing framework. I'm just starting a Git branch called NJT review, so that I'll put any changes I make into that, and then you'll get that as a pull request.
Okay.
So use test that sets up a few things. It'll tell us here, like it's adding test that to suggests. They've got a special thing where you want a certain version of test that. It creates a folder called test that, or tests. I'm going to test that. And then I'm going to write a test. I'm going to say use test theme -ru. It's going to open up and create this template for me here. So this starts with test underscore that multiplication works. And I'm going to say here that like theme ru is consistent.
So that's just saying, like a message basically that would display somehow, is that right?
Exactly. So when you run tests, so if we run tests now, and I click this little, so see how RStudio's got this stuff baked in, it says run tests. If I click on that, it'll find this testing file. Okay, well, we'll get an error about Statamica.
Do you want me to give you a link to it? It's just, oh wait.
We can do that, or I can,
hold on.
Yeah, that might be easiest.
Yeah, hold on. It's, I realize it's private. I don't think it needs to be private though.
I can just comment it out of the description for the moment.
Whatever's easiest for you, just let me know.
I'll just comment it out for the moment. It might be easiest if I install it actually, if that's possible.
No problem. I am just going to make it public. Okay, I'm gonna put in the chat here a message that has a link to the package.
Cool. So I'm just going to install this. Have you seen that package?
Yeah.
So it's nice. It allows you to install from GitHub.
Right.
Which is kind of.
Yeah. Some
it also has.
I ran into with it, but for the most part, I really like it.
Yeah, there is. Yeah, like every now and again, I've had like the occasional issue, but I like these little emojis and the fact that it just seems like it feels nicer, which is good.
Yeah. I think it was someone, the client was working on a Windows machine and somehow something got messed up. I don't remember what the issue was, but.
So the test I'm going to write here isn't something that I think is actually talked about enough, which is you can test your data visualization. And it's really cool, and I'm going to show you how that works. So, all right, install deps again. I'm pretty sure we should have most of the other packages installed. We'll update some from CRAN. Done. So normally when you're working in your R package, you might do like load all, just to load all the functions from a package. I see I've got theme RRU. Let's just say I do empty cars, try and remind myself of the column. So if I do ggplot library, ggplot2, ggplot empty cars, and do miles per gallon and HP, horsepower, and I do geom point and say color equals factor sil. Cool. So we get a ggplot. And then if I do plus theme RRU, then we get this nice theme. Great. So I'm going to assign this to an object. I'm going to call this gg theme RRU. So we run that, and then we say, using another package called vdiff-r, expect doppelganger. So here we say title equals theme RRU, and then the figure is going to be gg theme RRU. So all of this might look a little bit strange at the moment. What we're doing is we're saying, make a plot, test the plot. So I run this test. We're going to get a warning that says adding a new snapshot. It created this folder snaps, and then there's in here an SVG image, which is like a text encoding of an image.
Oh, I think I see where this is going.
Yeah. So now, if I go back to our themes, and let's just say I change this slightly, I change what would be something. If I hit save on this, actually, it's going to reformat your code because I've got the air formatter installed. So
that's fine. You can do that.
Okay. That one won't be quite as good. Let's change the base size to like 26.
Mm-hmm.
Okay, just reformat all your code. Sorry, but okay. So then, when we run this, okay, cool. So now if I run load all again, and I recreate this, and I look at this plot, it's all like a little bit bigger.
Mm-hmm.
All the base things have been increased. So now if we run this test, what do you think will happen?
I mean, my guess is it's gonna compare the image that gets created to the one that got created before and see if they're the same. Is that accurate?
It is, and it gives us a message, and it says run this to review changes. So it says run test that snapshot review. And if you click on this, it actually opens a little shiny app, which is really cool.
So it's like comparing.
So this is the straight difference, which is like there's all this red and stuff. But if we look at toggle, you can sort of click, but change the aspect ratio to make it a little bit bigger. You can sort of see what the changes are. And one of my favorite features is there's this slider. And so you can sort of slide across to see what the differences are. So most of the time, like 99% of the time when I've run my tests like this, there's been some change in ggplot and the image has changed very slightly, and it's like, that's fine. Other times there've been like some reordering of things due to like some new sorting that I applied or something, and I actually really didn't want that to happen because the visualization looked really different. And another time that this changed was we actually applied this idea of snapshot testing for images for when we were doing COVID modeling work, and we needed to compare the data visualization we were creating each day with the previous day. That was really useful because for the most part, like the images would always be different, but we could strictly compare them. And a couple of times there was a plot that was totally different because the data had changed and the formatting had changed. The plot was just like, it didn't make any sense. And having a way to specifically be like, where's that change? Okay. Rather than being like, oh, that plot looks different. What does the one look like yesterday? I'm not sure it's overridden. Like,
yeah.
So I might just revert that change there, but that's the general, that's a way how to write a test. And this idea of snapshot testing, so I'm just going to revert this change to the themes, which will also fix the styling back to how you had it. So that's one test. Have you got an example of like something that just changes some data, or is there like an error message if you got like a stop call in there or something?
Good question. Yeah, let's see. I mean, this one actually might not be the best. I can explain it to you, but it's very particular. Basically, we use, we make a lot of PDFs, and we use the Page.js JavaScript library to create them. What you do in Quarto is you just have a special CSS file but it makes an HTML file, but then you need to convert that HTML file to PDF with the Page.js CLI. So I had one of my consultants write a function in R that just takes the input of the HTML file and convert it to PDF. Does that make sense?
So we could quickly test this error message. So snapshot tests are a way to check error messages as well. You can use snapshots for a few reasons. Like sometimes it's like you want to ensure that the exact output is the same. So let's write a snapshot test after this one. So I'm going to write a separate use test, render page.js. And I'm going to say fails as expected. So if I have this function and I put in a file path, let's just say like empty path is just character with nothing in it. So that'll just return sort of 0. I would expect that this would fail. So this is another way to test that things are happening as you want. So we can briefly test this interactively. Well, I should probably create that object. Cool. So now we can write, so I could write expect snapshot. And then the recommendation is you write error equals true first. And then x equals the command that you want to test. So if I run this test, it's first going to show me a warning. So it's saying, hey, I'm creating a new snapshot. And we can see this inside our tests folder here under snaps. We have this render-page-js.md. And it says, with this code, we get this thing, like this message. And then if I run tests, we now get a pass. And that's specifically testing that this error message is the same. This is slightly better than writing something that says expect error, because you get more information. But yeah.
So just to like step back for a second, like I'm not as good at writing these functions or developing packages as someone else. The way I might like test it is to interactively, go in and try to run my function with, whatever the file path is, just the blank or something like that. But what you've done here is set it up such that we can ensure that if there is a blank or an empty character for the path, we know confidently that it will fail now as well as in the future. Is that the basic idea?
That's a really good, it's a very good summary, because you might interactively test that, be like, okay, good. Or you just might not know if it does fail appropriately. Because sometimes I've written code where I'm like, I've crafted this error message, great.
Yeah.
And then it turns out the way I've written the code, the error message actually never triggers, because I've like mucked up the way I state my logical conditioning to ensure that the error message works. So so it's like actually making sure it is going to fail when you think it will.
When you want it to fail.
When you want it to fail, yeah.
Right.
I've just changed this code slightly to be a little bit clearer, to say that when file path is character, so it captures that. So this test will now fail. But if we look at this again, it'll say snapshot accept or snapshot review. And I click on that, it'll open up another Shiny app. And it'll show you which parts have changed, which is kind of nice. In this case, I know that this is fine, and I can accept that. And like you now confidently know that this function will fail when you expect it to. And you'll also have more information about the error message. And one thing I've enjoyed about this, I went through a pretty deep process on this, is it forces you to relook at your error messages, which they're really hard to write. And depending on how important the error message is, like it might then cue you to say like, actually, like, do I want to say something else? And so I think that's another thing about testing, is that it forces you to return back to your code and look at it again with kind of fresh eyes, because you kind of have this robot now that kind of has such strict ideas on how to view the world about what to test with this thing.
When you're writing these tests, would you then be kind of doing, like, as you've been doing, like running the test, making sure that everything passes as you develop your package? Is that the idea?
That's the idea. Again, I think I've jumped to a non-standard way to use tests, which is this like snapshot testing idea, because the idea is that you create a snapshot that you then compare against, which is kind of a lot of tests would be something like, that does this return a data frame, or does this return something that has a certain size or dimension. But yeah, the idea is that you write these tests, and then also if you encounter bugs in the future, I'm sure you've encountered bugs in this package at some point. So when you run into a bug, you go, okay, I ran into a bug. I should write a test that captures that bug and identifies it. And then I know that once that test passes, the bug has been fixed.
Hmm.
So
Yeah.
that's,
I
yeah.
mean, just thinking about it, it seems like one challenge with writing tests is knowing what to test for,
Hmm.
because like, how do you preemptively anticipate what the problems could be? Do you have suggestions for how to do that?
Yeah, I always found this hard. It felt like the easiest thing to do was make sure that the outputs are what I expect.
Hmm.
Um, and in doing so, I found that my confidence, assuming that it always returns a data frame or it always returns variables named a certain thing,
Hmm.
aren't always right.
Hmm.
Um, and so even just capturing that, I feel like that's my initial like expectation of just saying like, okay, I always expect this to return the same output, and then you might then further test that idea and be like, okay, well, let's say what happens if I give it really garbage input? Like, what happens? And you might expect it to fail and it doesn't, and you're like, oh, that's
Hmm.
very bad. I
Hmm.
should do something about that. But it is tricky to start to identify like what future problems might I have. But I find that in establishing some initial baseline, um, that brings you to a place that's closer to identifying these other errors.
Hmm.
But I do agree with you. Like it is kind of hard to anticipate what the errors might be.
Right.
But this process, at least establishing some kind of baseline and getting some tests written,
Yeah.
will allow you to kind of start to view this. One way to, so like we can look at this package called cover, and if we do a report on our code through some process that's a little bit unclear to me, it'll tell us what the coverage is. So it'll say here that for our themes, we've now tested this theme, except we haven't tested the case for when void is true.
Hmm.
So I should write another test that does the same snapshot test with void equals true, and I should do another
Uh-huh.
one with grid lines equals false and that sort of thing.
I see.
Does that like make sense?
Yeah, yeah, that makes sense. I mean, I've always
And
wondered,
then
I always
some,
see like those coverage percents and I never know what it's talking about. So,
yeah, it basically does a way of like testing to see which parts of the test cover which bits of conditions of the code.
yeah.
And so in this case, we might say, okay, well, it looks like with this, the package Quarto is always required, so we should have a way to test if Quarto is actually installed, if it does fail appropriately. That's actually possible with testing. There's an idea called mocking, which is you can, in one given test, you can say, pretend that this function returns this thing. And so then you could write this in such a way that it will return false if it can't require the namespace of Quarto.
Mm. Hmm.
So then, like, you can test that. Um, that's that one. Turns out the colors one has been tested, apparently, according to the test so far. And I
Huh.
guess perhaps that's implicit in some other things. But oh, this is nice. It's a nice little bit of code. Have we got enough time to talk about another test, do you think? Or
Yeah, let's do one more and then we can wrap up.
cool. Just trying to think about any other tests that might be. Just looking at this code. I haven't seen Tibble view before. Is that just like a function that
Where is
opens up the
that?
viewer? That
Yeah, yeah.
was entirely cool.
That one I don't really use much anymore. It's like to connect to a video hosting service to like upload videos. I ended up not really
Hmm.
using it. So.
Yeah. Um,
That one I can explain to you if you want. Probably the simplest. I'm thinking of like simpler ones. I mean, the colors one obviously is pretty simple, but the tidy census ones are probably fairly simple.
mhm,
Like that get ACS race ethnicity. Like I know
mhm,
you talked about, for example, being able to ensure that variable names are
mhm.
what you expect. So maybe that
Yeah.
would be one we could do.
Yeah, great. Okay, so let's write a test. Use test. So if I just put this function in here and look at it, it fails because I need to provide, I need a
Oh,
census API key. Okay, so we have this data. We're testing out if this data works. If this how this function works. So we can do another snapshot here, which is that get ACS race ethnicity. I would say get ACS race ethnicity returns. So what are some things here? Like you expect these columns,
Yeah.
and it seems like the work that you're doing inside this function is to make sure that they're called this. Like that's
Yep.
important to you.
Yeah.
Cool. So I'll talk about this in a slightly roundabout way. One way that people might do this is they might say expect equal, and you'd say names of this.
Mm-hmm.
I'd say ethnicity. So put this into an object, and we might say the names of this are equal to this. With like a C at the front there. Another way to write this is to write expect snapshot names of this. These two are the same test, effectively. One of them I'm manually writing the things there, and the other one, it's going to extract this, store it in a file, and then I have to be sure that that file is the same. Another thing that we might do is expect equal, and I might say dim of ACS race ethnicity. I'll expect the dim to be 416 and 5.
So in front of 16 rows and 5 columns.
Exactly. Or you might also say expect equal, and then I might do, it's getting a little bit tricky. I could do the apply class. We could just say that you expect all the classes to be of certain things like this. And so that is like something like you want to make sure this always like return, like this might be a really useful test, because I would probably write this as something like expect snapshot actually, but just because I don't want to have to manually code this stuff in. So the idea of the snapshot is that you have some sense of like a golden state, like that you're really confident that you want things to stay as. So it's useful for like what we might call like a regression test. Like if this stuff changes, it has regressed and changed in the way we don't want. So all of these tests here are now establishing exactly what we expect from this data frame. And maybe there could be very specific things here. Like it seems like population group in here. If I did unique on this, like it seems like you would want all of these like factors to be there. Is that right?
Yeah.
Yeah.
I think so. I have to think about the data and but yeah, I think so.
And I guess that's part of the point of the of testing, is to like force you to re-examine all the things that you think are really instrumental in this. And so maybe in this, if going, oh, actually, these are all character, but maybe it might be that I want this as a factor because the factor can code that these are the possible levels.
Yeah.
But I might not have all of them or something like that.
Right.
So,
yeah. I mean, that makes sense. I mean, it seems like it's all variations on a way to say, this is what my function does or should do, and how can I kind of write tests that enable me to ensure that it actually does the thing that I expect it to do. Otherwise, something has gone wrong somewhere along the way.
Exactly. Yeah.
Cool.
That's a lot about how I think about tests. I think I want to say that there's probably some important points I'm missing here. I feel people like Miles McBain writes very good tests, and I feel like he would also have some additional thoughts on here, where I'd be like, oh yeah, of course I should have said this thing. I feel like I'm missing something here, but
this is great. This is a great way to see like what tests are, especially again for someone like me who's never worked with them. So this is really helpful. Nick, I'm gonna let you commit that, and then I'm gonna actually have to wrap up.
Yes, absolutely.
Cool. Well, let me just ask you a couple kind of final questions. So, this is a great introduction to how tests work. I'm curious, you're doing consulting work now, you're out on your own. Is this the type of thing you're doing in your consulting work? Are you spending time writing tests, and what else are you doing as part of your consulting work?
Yeah, so related to that is package review. So I recently did some work for some folks at NOAA through OpenScapes, through Julie Lowndes' group. So I did a package review for them where I recorded myself going through the process of changing code and sort of live commentary on the changes I would make and why I'd make those changes. And that's nice, I find, because that it's not just here's the updates to your code, it's sharing the process as well.
Yeah.
And yeah, in terms of like package development and that sort of thing, like establishing tests is also helping out future you. There's a quote from someone, I can't find it, but it's like, you're always collaborating with your future self. So if you can set up tests, then you're helping yourself in the future for if something comes up and there's some bug. And the other work I do in my consulting is statistical modeling development and also some mentoring. So I have a mentor at the moment. We meet once every so often and we just like discuss some of like where they're at with their R goals and that sort of thing. It's kind of like almost coaching and providing a sense of like, what do you know and what do you want to know, and maybe there's some ways I can help you get there or explain some concepts.
I mean, it sounds like it's recreating what you had when you were learning that.
Totally, yeah. It's absolutely the thing that I was, it's a thing that I really care about and I want to make work for people, and it's not something I'll do a lot of, but it's something I care about and I want to make that approachable for people.
Yeah.
But yeah, there's a lot of those are some of the things I've done. I recently wrote a targets pipeline for someone. They weren't able to share their data with me, but they could share the key structure of the data, and then I was able to simulate some data that had the same structure, do a bunch of tidy models analysis, exploring the variables with partial dependence plots and other things to see like what changes over what variables are important for predicting your outcome. And then they're able just to slot in their own data at the top and the pipeline ran, and then they had a report at the end. So those are some of the things that I've been working on so far.
That's awesome. And if people want to learn more about you, the type of work you do, what are the best ways to get in touch with you?
Yeah, the best way to get in touch is through my email and on my blog. So you can see my email on my blog, on my bio, or on my consulting page. So that's njtierney.com.
Cool.
And yeah, my email is my name, nicholas.tierney@gmail.com. So that's the best way to get in touch.
Great. Well, Nick, thank you so much for chatting with me about R in general, showing me about tests. It's been really informative, so I appreciate it.
Great. Thanks, David.
That's it for today's episode. I hope you learned something new about how you can use R. Do you know anyone else who might be interested in this episode? Please share it with them. If you're interested in learning R, check out R for the Rest of Us. We've got courses to help you no matter whether you're just starting out with R or you've got years of experience. Do you work for an organization that needs help communicating effectively with data? Check out our consulting services at rfortherestofus.com/consulting. We work with clients to make high-quality data visualization, beautiful reports made entirely with R, interactive maps, and much, much more. And before we go, one last request. Do you know anyone who's using R in a unique and creative way? We're always looking for new guests for the R for the Rest of Us podcast. If you know someone who would be a good guest, please email me at david@rfortherestofus.com. Thanks for listening, and we'll see you next time.